Hello everyone, this is Saurabh. Welcome to the Options Engineer channel. In this session, I'm going to cover an educational research example around engineering a 5-point spread. This example is on a SPX 5-point debit spread. The idea is simple. A normal 5-point spread has maximum settlement value of 5 points before debit, but by changing the construction slightly, there can be a targeted area where the structure settles closer to 10 points before debits. I'll use simple math first, and then I will do a quick replay of a real trade example. The goal is not to present a trade recommendation. The goal is to show how payoff engineering can change the shape of the outcome. Here is the simple call side math. A normal 5-point call spread using 7750 and 7755 can settle at 5 points if SPX finishes above the upper strike. Now compare that with an engineered call structure. Long 7750, short 2 7760 calls, and a long 7765. If the SPX closes around 7760, the structure can settle around 10 points before debit. But if SPX moves beyond 7765, both structures converge back toward the same 5-point settlement before debit. So the engineered version is not simply better everywhere. It creates a local payoff peak. That is the key engineering idea. The same idea can be mirrored on the put side. A normal 7750 to 7745 put spread settles at 5 points if SPX finishes below 7745. An engineered put variant using 7750, short 2 at 7740, and long 7735 can settle around 10 points if SPX finishes near 7740. But if SPX continue lower through 7735, it settles back to about 5 points before debit. So the design creates a target zone. It does not remove risk, and it does not guarantee that SPX will finish in that zone. It changes the payoff shape. Visually, this is the difference. The normal spread has a single plateau. Once the spread is fully in the money, it settles at 5 points before debit. The engineered version has a local peak. Around the engineered center, the settlement can be closer to 10 points before debit. Farther beyond the outer strike, it behaves more like the normal 5-point spread again. This is why small construction differences can matter. The structure is buying a different payoff shape, not just a slightly different trade. At this point, I will move into a quick replay of a few settlement scenarios on the Options Engineering Operating System OS. So now we are on the Options Engineering OS and looking at a couple of weeks back of data here for going through some scenarios. So we have a call spread here that we're going to look at locking in or buying for simulation here, and similarly engineered structure or a broken wing butterfly. So let's take an example here. So I'm going to lock in the call spread and a call engineering variant for a 5-spread debit spread. So now we can see the debit paid in this case is $100 and the debit paid in this case is $116. So there is slightly higher debit, and we're going to just walk through how this example plays. So we continue throughout the day, and we can see the debit is changing for both of them and is approximately in the similar ballpark as the market is moving. And I'm just going to try to get to the close of the day and see how it shaped out. So we can see here that as the market in this scenario closed at 7757, and the debit on the call spread was 7750 and 7755, and on the engineering variant it was 7750, 7760, 7765. So the market closed above 7755, and the call spread locked in a P&L of $400 for $100 of initial debit or $100 of capital at risk. The engineered variant or a broken wing butterfly here had a capital at risk of $116, but for $16 more, it was able to get a P&L of $648, that is $248 more. So significantly higher P&L in this case. So this was one scenario. Let's walk through a couple more scenarios. Now we are going to replay a scenario where the market eventually finished beyond the call spread and the engineering variant of which had the 7755 as the endpoint. So I'm going to lock in the two spreads here, and we'll just walk through these quickly. So as we can see here, we paid a debit of 150. Here, a debit is 180 for this example. So we continue, and we can see how the P&L and is shaping up here as the market moves into that range. And at the end, let's see what happens. So we can see here as the market finished beyond the 7740 and 7745 call spread, and also beyond the broken wing butterfly and engineering variant of 7755. So the debit spread made slightly higher in this case because the paid CAR or the debit to begin the trade was lower, and the engineering variant had a lower P&L because the debit was slightly higher, or the paid CAR was slightly higher. So that's another example here. So now we are going to take a look at an example on the put side. And this is quite late in the day, and where there is a high probability of getting outside that 5-point range if the market moves in the last few minutes and getting a higher payoff. So, but it doesn't happen always, as we all know. So this is just a reference example. So let's look at this SPX replay where the market was at 7685 around 12 minutes from closing. And we are going to lock in the debit spread here. And we can see the debit in this case is 155 for a put spread of 7680 and 7685 debit spread. And similarly for the broken wing put spread, the debit is $204. Is higher as it's close to the end of the day. But from an example standpoint, we can now walk this example towards the end of the day and see how this plays out. So as we can see, the market starts moving down, and market closes at 7674.1, and the P&L in case of a debit spread was $345, and the P&L in case of the engineered variant for the put spread was almost close to double for slightly higher debit paid upfront for the put variant. So there is the trades can go, these are directional trades, and they can work certain times because of the payoff structure. But if the market doesn't move in that direction, both of the trades would end up losing the debit that was initially started with. The extra cost is not just an expense, it is the design decision. Normal spread may be simpler and cheaper. The engineer variant may cost a little more. The engineering question is whether that extra debit buys enough useful payoff shape. If the target zone is reached, the difference between the 5 minus debit and 10 minus debit can be meaningful. If the target zone is not reached, the outcome can be much less attractive. I want to frame this carefully. This is payoff engineering, not prediction. The structure does not know where SPX will close. The market can move past the zone, stop short of the zone, or close near the zone. What engineering can do is define the payoff shape before the trade is placed. Pricing tells us what that shape costs. Structure tells us whether the payoff expands. Replay tells us whether a design behaved as expected. That is the option engineering mindset. This fits directly in the options engineering workflow. First, observe the pricing. Second, compare the normal structure with engineered structure. Third, measure the debit and capital at risk. Fourth, replay the outcome and ask whether the payoff behaved as designed. That is why I keep emphasizing the full system. The trade itself is only one part. The design, pricing, risk, execution, monitoring, and replay all matter. The three takeaways are simple. First, a normal 5-point spread and an engineered variant can share the same outer settlement, but the engineered version can have a different local payoff profile. Second, a small extra debit can matter when it buys a higher payoff zone. Third, the process should remain educational and research oriented. Design the structure, understand the price, measure the risk, replay the outcome, and improve the system. If this research is useful, please like, subscribe, and comment with questions you would like me to cover next. You can scan the QR code or visit the optionsengineer.com for more research, videos, and educational coaching. Thank you for watching, and I will see you in the next video.